Hi, my name's Andrew McLaren, and I want to help you with balancing out ionic formulas from a name, not using the swap and drop method, which can cause some issues. So we're going to compare that with doing some simple algebra, um, and you'll see why I prefer algebra over the swap and drop. If you're getting errors with this stuff and you're not sure why it's different in some situations, this would be a good video to watch. So if you look at sodium chloride, the Na Cl, that would be the formulas for those two. When we try and figure out how to balance them, that sodium, sure, you can think of that as having like a plus one and the chlorine as having like a minus one. And so you can put those together and just write it out like NaCl. So how I think of this is that this is like a 1 times a plus 1, because there's one of these and there's one of these being added. Now there's 1 times a minus 1. So the overall charge is 0. So that's kind of the big picture. How I think about doing this is with a little algebra. It's not about what people call the swap and drop, which is you just take this charge and you bring it down there, which works for a number of these, but you'll see pretty soon that that doesn't always work. But the algebra method does always work. So if we're talking about magnesium chloride, you've got Mg, which is plus 2, and then you've got chlorine, which is a minus 1. And if we want to think about this, this is saying that there's like a plus 2, and we need to figure out how many times to multiply that, and a minus 1, how many times we need to multiply that to get this to be 0. So to do this, you would have 2 times this and 1 times that. So just to do a little bit of color coding here to help you all follow along, that we're saying that there's now one of these and 2 of these with their corresponding charges. So if we want to write this out, now we've got 1 magnesium and we've got 2 chlorines, and that's balanced out. So it is neutrally charged. So when we're doing these ionic things, we're basically saying how many of the anion to how many of the cation would be present, um, which is just a matter of balancing out their charges. They'll form a repeating pattern with those charges in that ratio. So there's going to be twice as many chlorines as there are magnesium in that solid. So if we talk about the sodium oxide, it's very similar. You've got that sodium plus 1, oxygen plus 2. So if you put those together, you've got a plus 1, and you've got minus 2, and you got to figure out what numbers go in front. You may be seeing this as a 1, a 2, and you would be correct. So we've got 2 of these to every one of those. So we don't write the 1 in here if it's just a singular thing, kind of like the sodium chloride and the magnesium. So we're going through some of the easier ones. Now it's like, okay, yeah, all of those would have worked for the cross and drop, but then these 3 have some various issues with the cross and drop method. So the magnesium oxide, we've got magnesium 2 plus, oxygen minus 2. So if we add those together, the numbers just cancel out as is. So we don't need to multiply them by anything, so it's really being multiplied by 1. So this is just magnesium oxide written like that. So it's much easier to do that with the algebra to like understand what's really going on here. So we don't want to just like get the answer. We want students to really understand what we're balancing and how we're tracking these things. And to me, doing this with a short algebraic expression is the best way to do that. And you'll see a couple more clarification points around like polyatomics here. So if we've got magnesium, that's going to be 2 plus. And then let me just double check. Did I pick the right one for this? I think I did. Then let me just double check. Yes, I did. So sulfate is SO4 2 minus. So when you put those two together, it's just a magnesium with 1 sulfate. So you might want to put parentheses around this, but if there's just a 1 outside there, you just don't write that in. So people might get confused because there's a subscript here with the 4. That's within the polyatomic ion, so that isn't really what we're putting in terms of the algebraic expression. So how I would help students see this is to do a little bit of color coding here, and we can do the magnesium. There's 1 of these, and there's only 1 of the sulfates. So we've got a minus 2, and there's 1 of that. And then with the magnesium, there's plus 2 charge per ion, but there's 1 of that. And so when we write that out, they cancel out, give us 0. And we can see how they cancel out, and we can also keep track of how this is talking about charge per ion. And so we can really get about what is these subscripts with this type of thinking and clarification here. And then for this last one, we've got aluminum. Aluminum is plus 3, and then you've got NO3 minus. You've got the subscript, which might throw people off again, but if you were to think about this in terms of the charge, there's only 1 of these, and there's 3 of these here. So really what we need here is an Al and then NO3, and there's going to be 3 of those. And to keep track of the algebra here, you can imagine what I'm going to do. We've got a 1 there, 3 here. So this is basically saying that you've got a plus 3. You're going to need to times that by 1. And then we're going to add to that a minus 1, and we need to have 3 times of those. And those do cancel out when we keep track of the algebra that way. But people can get a little bit messed up with the swap and drop because like, oh, I've already got 3 down there. No, you do not have 3 down there. That's within 1 polyatomic ion. So it helps to really think about these in terms of the charge and the number of ions. So if I were to generalize what we've talked here, there's the charge times the number of ions, and you do that for the cation, and you also do that for the anion, so the charge and its number of ions, and that should add up to 0 between those two things. So whatever number you have for the number of ions times the charge per ion, and then you add them all up, and they should cancel out. All right, I think that's it. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there. And we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.